Okay, in this video, we're going to do a quick review on implicit differentiation that you may have encountered in your first calculus course. All right, so we know we're going to use implicit differentiation when you're given an equation involving x and y, such as this, the natural log of 2x plus y is equal to x plus 1. And to solve it, you'll need to use all your appropriate derivative rules, like your power rule, product rule, quotient rule, chain rule, as normal. But then when you have a y term, like right over here, you also need to multiply by y prime, the derivative of y, right? And that's the implicit differentiation piece where we're really just applying the chain rule at multiple steps. So let's take that example and say, hey, what if I want to find that derivative of the natural log of 2x plus y being equal to x plus 1? And I want to find dy dx, the rate of change of y with respect to x. So we know that the derivative of the natural log of u is du over u, right? And if we let u be 2x plus y, then the derivative of u with respect to x, right, because we're saying our variable is x, is going to be du is equal to 2 plus y prime, right? Another way that we could write this, right, is more clearly is we could say, hey, du dx, the derivative of u with respect to x is 2 plus dy dx, right? But y prime is a shorter way of writing dy dx, right? We've got the Leibniz notation, but also the Lagrange notation that we could use. So if we differentiate both sides of our equation, right, the derivative of the natural log of 2x plus y, well, that's that du over u, right? We're going to have 2 plus y prime all over 2x plus y, and the derivative of x plus 1 is simply 1. Right, we'll just call that equation 1. So if we rearrange equation 1, right, by multiplying by both sides, so I can take this 2x plus y and multiply it by the 1, I now have 2 plus y prime is equal to 2x plus y. Solving for y prime then leaves us with our solution that dy dx is 2x plus y minus 2. So in other words, the slope is dependent on both the x and the y coordinate. If we look at another example, a similar example, that we have, hey, if x cubed plus 3xy plus 2y cubed is 17, and we want to find dy dx in terms of x and y, well, we need to differentiate both sides. So the derivative of x cubed is 3x squared. The derivative of 3xy would be 3, but then we have this product, x and y. So I'll have the product rule, first times the derivative of the second, plus the second times the derivative of the first. And the derivative of y we'll simply say is y prime. Then we have the derivative of 2y cubed, which would be 6y squared using the power rule. And then the chain rule being applied, the derivative of y is y prime, and the derivative of 17 is 0. Right? So if we group our terms, if we group our terms, so here is a term that has y prime, and then here is another term that has y prime. So I've got 3xy prime plus 6y squared y prime. And I can take my other terms and move to the other side of my equation, negative 3x squared minus 3y. So solving for y prime, right, I could factor out. I could factor here and say that y prime times 3x plus 6y squared is equal to negative 3x squared minus, or excuse me, plus 3y if I was going to factor out a negative. And then I would end up with my solution, right? If I ended up dividing everything else by 3, x squared negative x squared plus y all over x plus 2y squared. So note, if this was a free response question, right? If this was an open response question where the focus is on can you implicitly differentiate, there would not be a need to simplify. But if your instructor wishes for you to simplify, be sure that you do. Okay? In the next video, we'll go through some examples.